Visualizing the body Jacobian for 5-hour planar robot. See here, there are 5 links, 1, 2, 3, 4, 5, and 5 joints, 1, 2, 3, 4, 5. We want to find JB3. So wrist joints we will rotate turn by turn. First, this joint rotated by θ4. The wrist joint considering rigid body. So this one is rigid body. So these two branch rotated by θ4. So now the orientation of this, say B dash reference frame. This one is B. This reference frame is B. After rotation, this is B dash. From this joint, we are rotated joint 4. We want to find JB3. So we have rotated first joint 4 up to θ4. And then after, this one is rotated by with this axis θ5, and this one is θ4. This one is θ4, and this is the tip. So this reference frame B, this reference frame B dash, further rotation, this one, after further rotation, the reference frame attached to this is B double dash, and attached to this and this same, say B dash, and this one is the original reference frame, fixed frame. So we want to find TBB dash. According to theory, it is e raised to B4 θ4. And from this, we want to find TBB double dash. It is e raised to V4 θ4 into e raised to B5 θ5. This one. See here. Visualizing the body Jacobian. Now let's derive the third column JB3 of the body Jacobian by inspecting the figure according to equation 5.18. The ith column of JB of theta is JBI of theta. Its adjoint representation of e raised to minus Bn theta n dot 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 e raised to minus Bi plus 1 theta I plus 1 into Bi. Here I is we have taken 3. So this one. Yes. So for I equal to n minus 1 to 1 with JBN is Bn. The screw corresponding to joint 3 is written B3 in B frame. This one. First joint, second joint and third joint. It is written B3 in B frame, body frame. When the robot is at its 0 configuration, clearly the joint variables θ1, θ2 and θ3 have no impact on the body twist resulting from the joint velocity θ3 dot, because they do not displace axis 3 relative to B. This one axis 3. So we fix those joint variables at 0, making a robot a rigid body B from the base to joint 4. This base to 1, 2, 3, joint 4. If θ5 equal to 0 and θ4 is arbitrary, then the frame B dash is at TBB dash equal to e raised to B4 θ4 is the new end effector frame. Now θ5 is also arbitrary, then the frame B double dash at TBB dash equal to e raised to V4 θ4 into e raised to V5 θ5 is the new end effector frame. The column JB3 is simply the screw axis of the joint 3 expressed in B double dash. This one. Since B3 is expressed in B, we have JB3 is adjoint of TB double dash B into B3 according to definition. But we have this TB double dash, so we have to take inverse. This one is the inverse of this. So adjoint representation of T in B double dash inverse into B3. and this one is nothing but adjoint representation of e raised to minus b5 theta 5 into e raised to minus b4 theta 4 into b3, where we have made use the fact that T1 T2 inverse is T2 inverse into T1 inverse. Order changed, and this formula for JB3 is precisely equation 5.18, this one, for joint I equal to 3. So again repeating equation 5.18, JBI of theta is adjoint representation of e raised to minus bi theta and dot e raised to minus bi plus 1 theta I plus 1 into bi. And for I equal to n minus 1 to 1 with the JBN is Bn is the generalization of the reasoning above for joint any joint I equal to 1 to n minus 1 or n minus 1 to